Okay, in this video, I will go over the mechanism for acetyl formation. So first things first, notice we have a ketone. I just underlined this part right here. We have two equivalents of an alcohol. We have a catalyst, an acid catalyst, and THF at 65 degrees Celsius. That will make an acetyl and will make water in the process. So the first thing that you have to do is an acid-base equilibrium step. So acid-base equilibrium, and that's with our catalyst and our THF. So we'll take our THF and our catalyst. So this is our catalyst. Oh shoot, getting ahead of myself. This is our catalyst. This is THF right here. React that with THF. Basic lone pair on our oxygen. We'll take that acidic proton, kick these electrons in that bond onto the oxygen to get a protonated THF. We'll also get our methane sulfonic acid, but deprotonated. So O minus, oxygen, oxygen. So that's just an acid-base equilibrium, like a little workup step right there, because we're going to be using a lot of these protons in this reaction. So we'll take this guy right here. And the first thing, or I should say the second thing, is we are going to add a proton onto our ketone, specifically the oxygen of our carbonyl bond, this guy. So second part, we'll take our ketone, react that with our THF that is protonated. Lone pair is going to take that hydrogen or that proton, shift those electrons back onto our THF to get a protonated ketone. Sorry about that. So since this oxygen's protonated, this carbon right here is more has a larger delta plus. It's more electrophilic, so our nucleophile will attack it more easily. And our nucleophile is our alcohol. So the third thing that we're gonna do is react it with our alcohol. There's a lot of steps. So third part, we have an alcohol. Lone pair in our alcohol. There's two lone pairs, but one of the lone pairs will attack right there on our carbon. Shift those electrons back up. And then we'll get something that looks like this. We have an OH, our alcohol attached. We still have that hydrogen on our alcohol, and now we have a positive on that oxygen, positive formal charge. Okay, fourth thing we're gonna do is we are going to use another molecule of THF to deprotonate this oxygen. Some professor will let you do a proton transfer, but some will dock points, so I'm just going to do the long route. So oxygen right here, this is THF. We are going to attack that proton, shift those electrons back onto that oxygen to give us something that looks like this. Now I'm going to erase this stuff so we can see everything gets a little bit neater. As you can see, there's a lot of steps. So pause the video, write this down on your piece of paper, whatever you're using, because I'm going to erase all of this and then keep going with our reaction. So let me do that. Okay, so our last step we were left off at was this guy. Okay, now we are going to use a protonated version of our THF that we got in our last step. When we extracted a proton from our alcohol, we got this protonated THF. So we'll take a lone pair on this oxygen, attack that proton, shift these electrons back onto the THF to give us this right here. OH, H, positive formal charge. Now, what is this? Well, this looks like water. So what we're able to do is take the electron lone pair on this oxygen, shift down here to make a double bond, and kick off our water as a leaving group. So we'll get something that looks like this, positive formal charge. If you don't know formal charges, you should probably look up a video on that. Okay, so now we are here. This carbon right here is now delta plus again, really large delta plus. So we're going to take our second equivalent of alcohol and attack that carbon. So we're going to react that. I'm going to try to fit this in. Lone pair on the oxygen, attacks right here. Shift these electrons back up. We'll get something that's not good. That looks like this. Now we have a positive formal charge on this oxygen. We don't like that. We want to extract that proton, get rid of that. So I'm going to redraw this guy down here. So we're going to take a molecule of THF to abstract that proton, shift these electrons back onto here, and then we'll get our final acetyl product. So if you have any questions on this video, or if something didn't make any sense to you, just leave a comment down below and I'll make sure to answer it. Thanks for watching.